In this lesson, we're going to look at how to name various types of ionic compounds using the IUPAC method. So the first type are the binary ionic compounds. So binary ionic compounds are compounds that contain only two different elements. Not necessarily just two atoms, but two different elements. So examples, NaCl has sodium and chlorine. MgO, magnesium and oxygen. And then FeCl2, iron and chlorine. So how do we name a binary ionic compound given the formula? So the first thing you do is name the metal, just the way you find it on the periodic table. Then you're going to name the nonmetal, but you're going to change the ending to "ide," I-D-E. And you're going to ignore the subscripts. So those little numbers, you're just going to ignore them. So here's an example, MgCl2. So Mg is magnesium, the metal, and then Cl, the nonmetal, is chlorine. So we're going to put that together, magnesium chloride. So give these ones a try. Note that hydrogen can act as either a metal or a nonmetal. If it's listed first, it's acting like a metal, and you would say hydrogen. If it's listed second, it's like a nonmetal, and then you would say hydride. So here are the answers to those questions, so feel free to pause and check your answers. Now, how about going the other way? So we've got the name, we need to figure out the formula. So what we're going to use is the crossover rule. So you're going to look at your name and you're going to write the formula for the metal cation and the nonmetal anion. Then you're going to determine the subscripts by crossing over the magnitude of the charges. So you're ignoring the signs, the plus and the minus. You're just crossing the number. And then you're going to reduce the subscripts to the smallest ratio. So let's look again at magnesium chloride going the other direction. So the magnesium cation is an Mg2+, and then chlorine makes an anion that is Cl-, so -1. So there's our two ions. We're going to cross over the numbers, right? Remembering there's an invisible 1 there with that negative, which is going to give us Mg, little invisible 1, Cl2, MgCl2. So here's some more for you to try. Some of the transition metals have, so we know the pattern on the periodic table to figure out the charges of the main group elements, but the transition metals are a little all over the place. So some of those charges are given to you in your handout, which you'll get in class, the nomenclature additional info handout. So in table 1, you'll see some charges that you'll need to figure out formulas. So here are the answers to those practice questions. The next type of ionic compounds we're going to look at are ones that contain multivalent ions. So remember that multivalent ions come from the transition metals, and there's some transition metals that can have more than one charge. So when your ionic compound contains one of those metals, you need to add the charge on the cation in Roman numerals in brackets, right? So you'll need to refresh your Roman numerals. Really, the only ones you're going to need are 1, 2, 3, and 4. And then you need to use a reverse crossover to determine what the ionic charge was. So let's look at examples, and hopefully that will become a little clearer. Okay, so we're going to name this FeCl2. So based on our previous way of naming, we would call this iron chloride. But iron is one of those special metals that is multivalent. So we need to figure out which iron ion is actually in this compound. So what we do is we do a reverse crossover. So take the little 1, goes up with chlorine, the 2 goes to iron. So this tells us that the iron had a charge of 2 and the chlorine a -1. At this point, you need to make sure the charge on the nonmetal is correct. So chlorine, yes, it does make an ion with a charge of -1, so it's good. But if it's not, then the formula was reduced and you're going to need to unreduce it. So because we know now that the charge on iron was 2, we would call this iron 2 chloride. So let's look at another example. So copper and oxygen, we've got all these invisible ones, so that tells us it's a Cu plus and an O minus. Now this is where it's important to do that check, right? The stable oxygen anion doesn't have a charge of -1. It has a charge of -2. So that means that we have to multiply both charges by 2 to make it match, right? So that oxygen has a -2. So now copper is 2 plus. So this is copper 2 oxide. So if you didn't take that extra step, you might have called it copper 1 oxide, and that would be incorrect. So you have to do that check to make sure that your nonmetal ion has the correct charge. So here's some more for you to try. Again, there's information given on your additional information handout for the ionic charges of the multivalent ions. They're also often found on the periodic table. So here are the answers to those ones. So check and see if you've got those correct. So now how do we go the other way? So it's the same process as when the ionic compound didn't contain a multivalent ion. And it's actually maybe a little bit easier because you're given the charge. You don't actually need to figure it out. Okay, so try these ones out. Same way you're going to do that crossover method. So write the ions and then cross them over to be able to get the final formula. And here are the answers for those ones. So now what happens if we have a polyatomic ion? So if your ionic compound is not binary, it's got more than 2 elements in it, it's going to contain a polyatomic ion. So recall that a polyatomic ion is 2 or more nonmetals joined by covalent bonds that all together have a charge. So an example, NH4 plus is the ammonium ion, SO4 2- is the sulfate ion, and so on your additional information page, most of the common polyatomic ions are given to you in table 3. So that additional information page you will have available to you pretty much all the time. So how do we name these things? So when the polyatomic ion is positive, so it comes first in the formula, you're just going to name the ion and then name the nonmetal as previously, change the ending to "ide." When the polyatomic ion is negative, it's going to come second in the formula. So you're going to name the metal first and then name the polyatomic ion. And you don't change the ending. You just use the name of the polyatomic ion. So here's some to give it a shot. And there are the answers. How about going the other way? So we've got the name, we need to figure out the formula. So again, you're going to use that crossover rule. But the important thing is that that polyatomic ion gets treated as a single entity. And so if there are more than one, you have to put brackets around it to say that there's 2 of the whole thing, not just 2 of one of the elements. So if we look at an example, calcium chlorate, so we can figure out that the calcium ion, calcium 2 or Ca2 plus from the periodic table, and then we look up the formula for chlorate, which is ClO3 with a -1 charge. So we're going to cross over. And then when we cross that over, we want there to be 2 of chlorate. So we have to put brackets around there to indicate that that 2 applies to everything in the brackets. So here are some for you to try. And there are the answers. So the last thing we're going to look at are the OxyAnions. So these are a group of polyatomic ions that contain oxygen. So examples are nitrate, sulfate, phosphate. There's also carbonate, chlorate. So they contain oxygen. So they're part of a series of 4 ions. So nitrate is part of a series of 4, and sulfate is part of a series of 4, etc. And they each differ by 1 oxygen atom. And so you change the name, the nitrate part, so you either add prefixes or change the suffix depending on how many oxygen atoms there are. But you do not ever change the overall charge of the ion. So sulfate has a 2- charge, so in its whole series of 4, it will always have a 2- charge. The only thing that will change are the number of oxygens. So the ion with the 8 ending, which are the ones I've given as examples, are given on your additional information page. But you're going to have to figure out the rest of the series. So the rest of the series can be figured out this way. So the one with the 8 ending is 3 down there, so whatever number of oxygen atoms it has, that's X. So we had looked at, say, sulfate, which is SO4, 2-. So that means X is 4. And then if you take 1 away, X becomes 3 in this case, and you change the ending from 8 to ite. So it becomes sulfite. And then when you take another oxygen away, so now there'd be 2, you add hypo in front of it. So you would have hyposulfite. You can also go down the chart, right, starting from that X, which for sulfate was 4. If you add 1 more to go to 5, you would add per in front. You would call it persulfate. Okay, this information is not going to be provided for you. So in other words, you're going to have to memorize it. So here's that sulfate example again, just to kind of show it all written out, right? So you would find that one on your handout, SO4, 2-, and then you can figure out the rest from there. The only thing that changes is the number of oxygen atoms. So what you need to remember basically is the order of the names, right? When you take away 1 oxygen atom, you get to ite as an ending. When you take away another oxygen atom, you have hypo and then ite as the ending. When you add an oxygen atom, you have per, and then you still have 8 as the ending.